Today we are learning about making inferences from a random sample. So first we're going to start out with our vocabulary. So it says population. So a population is an entire group of objects or individuals. So let's say a population, for example, could be all Miller students. Okay. And then a random sample is a sample where each individual has an equally likely chance of being chosen. So an equally likely chance of being chosen. So let's say that I stand by the cafeteria and my random sample is 20 students. Okay. So 20 random students. Okay, that would be an example of a random sample. Then our last word is an inference. So an inference is a conclusion drawn from evidence and reasoning. A conclusion drawn from evidence and reasoning. So it's basically saying that let's say I grab 20 kids to the side and I'm trying to figure out how many boys and girls there are at the school. So if I grab 20 to the side and there's, let's just pretend 10 are girls and 10 are boys, then I can make an inference or a conclusion that half of all the students at Miller are boys and half of all the students at Miller are girls. So that's what it means to make an inference. So let's go ahead and look at our first example. So it says Jennifer made a poll in her homeroom asking students about their favorite subjects. The results for her homeroom are given. All right, so history 10, science 8, math 5, reading 7. So how many people did she poll? So total, let's see, 10 plus 8 is 18, plus 5 is 23, 30. Okay, so 30 people. So if she polled her homeroom, we're either dealing with our population or our sample. So population or sample. Okay, so let's look down here. It says if there's 810 students in her 7th grade class. Okay, so that's telling me here that that is the population. So the population is the 810 in her 7th grade class. Okay, and then her random sample was the 30 students in homeroom. Okay, so if there's 810 students in her 7th grade class, how many can she infer would choose math as their favorite class? Okay, so we're talking about how many like math. Okay, so let's look at our sample. 5 students out of 30 liked math. So actually we're going to set up a proportion. We're going to say, so then how many students, we don't know, out of 810 would like math. Okay, so we're just doing a proportion, setting up a ratio on each side, making sure we have math over our total and math over our total. So now we know what to do. You guys are proportion pros, so we're going to do cross product. 30x equals 810 times 5. 1 times 5 is 5. 8 times 5 is 40. So 40, 50, divide by 30, divide by 30. 40, 50, divided by 30. 30 goes into 41 time. We get 100, bring down the 5, 105, 3, 30, 60, 90. So 3 would be 90. 5 minus 0 is 5. 10 minus 0 is 1. 150. 30 times 5 is 150. So 135 students. So 135 students like math. Okay, so since 5 out of 30 students chose math, then 135 students out of 810 would choose math. That is our best estimate, or that is our inference. Okay, so now our situation is changing. It says if there are 9,300 7th grade students in the district, how many can she infer would choose history as their favorite class? So now we're saying our new population, right? We're changing it is, the 9,300 7th graders in district. But again, we're using, we're using the same sample. So our sample is still the 30, students in homeroom. Okay. So again, this time we're looking at history. So how many can she infer will like history as their favorite? So we're talking about history. So 10 students out of 30 students preferred history. So how many students out of 9,300? Okay. So we can actually simplify by dividing both sides by 10. And then now we can do our cross product. Okay, so 3 times x is 1 times 9,300, 9,300 divided by 3. So x equals 9 divided by 3 is 3, 3 divided by 3 is 1, and then my 2 zeros. So 3,100 students would choose history. So based on the likings of our homeroom class, the preferences of our homeroom class, we can infer or make an educated guess, kind of, that 3,100 students in the district, 7th graders, would choose history as their favorite class. Okay, so we have a think, pair, share. So if you're watching the video, it's kind of hard to do a think, pair, share. So you're going to think and you're going to share with yourself. Okay, so our inference is made about an entire population precise. Why or why not? So you're either going to say inferences are precise. Inferences made about a population are, or you can say are not precise because. So, I mean, I would think about it. So, if I choose those 20 students from Miller and say that half and half are boys and girls, does that mean that's accurate about the population? Not necessarily, right? So it may not be precise, but it gives you a good idea. Okay, let's look at our second example. It says a shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 MP3 players and finds that 3 are defective. Defective means like they're broken, okay? How many MP3 players in the shipment are likely to be defective, okay? So in this situation, they chose a random sample of 50. Okay, so I'm going to put RS, random sample is 50. And then the warehouse has 3,500. So that's going to be my population, is the 3,500. Okay, so it said that 3 out of the 50 were defective, right? So they're saying how many out of the warehouse would be defective? The warehouse has 3,500. So how many would be defective out of that? Okay. So just do your cross product and solve. Y'all are proportion masters. 5x is 3 times 3,500. 0, 0, 15. 3 to 3 is 9, 10. 105,000, sorry, 10,500 divided by 5, divide by 5, x is 10 divided by 5 is 2, 5 divided by 5 is 1, 0, 0. So 2,100. So 2,100 defective MP3 players in the warehouse. Bam. Okay, so at that point, you are done with your notes. You have learned that you will set up a proportion, and one ratio will be your sample, and the other ratio will be your proportion. So now you're going to work on your independent practice. There is an answer check on Schoology, so it's an Excel document. So you will just download it and then check your answers when you finish. But let's go ahead and take a look at number 1 together. I'm just going to kind of help you set it up, okay? So number 1 says Happy Go Restaurant wants to know how customers feel about their service. In a random sample, 49 out of 50 customers said the restaurant was warm and inviting, and they enjoyed their meal. So if the next week they serve 630 customers, about how many of them will enjoy the service, okay? So it gives us here our random sample, and we say 49 out of 70 liked it, okay? So 49 out of 70 liked it. And they're saying next week there's going to be 630. So that's going to be my new total. There's going to be 630 people. So how many will enjoy the service? Okay. And then we're bumping it up a level. It says what percent of the customers probably will not return or recommend the restaurant? Okay. So this is a little tricky. I guess I'm going to have to help you guys solve it so that we can do B together. Okay. So cross product 70x equals 49 times 630. 0, 27, 54, 55, 56. 0, 0, 12, 24, 25, 0, 7, 8, 10, 3, 3,870 divided by 70. Okay, so press pause and divide. That means all of you. Pause, divide. Okay, so you finish it. We find out that 441 people like it. Right? So now this is saying what percent would not recommend it, not return or recommend. So 630 people went minus 441 people liked it. So 2, 10, 9, 8, 1. So now you're going to set up a proportion. So 189 people did not like it out of 630. So what percent is that over 100? So guys, these are proportions. You're great at proportions, and then using your percent proportions. So now you're going to work on your own and use your answer check and make sure to ask questions, guys. Good luck.